Hello Algebros! Today we are going to be solving equations that have radicals in them. I would recommend reading through all of this. I'm not going to read it because I'm just going to demonstrate it, but it has examples of everything. Also, your assignment's going to come from this page, and notice you can see the answers because in math the answers really are not the biggest importance factor. It's the process of getting there. So I'm going to just do a couple of these and get going. All right, so the first one is square root of x plus 1 equals 4. So all right, so anytime that we're solving equations, our goal is to find out what that variable is and using inverse or opposite operations to get there. And we have to unfold it, and we have to take it layer by layer, and you have to take whatever's on the outside first and then work your way in. So right now x plus 1 is being square rooted. It's underneath the square root. So the opposite of a square root would be squaring a number. So if we square this side, and remember when we're solving anything you do to one side, you have to do to the other. So we're going to square that. A square and a square root are inverse operations, so that goes away, leaving us with x plus 1 equals 4 squared would be 16. And subtract 1 from both sides, and we get x equals 15. Let's check to make sure that we have the correct answer. 15 plus 1, let's see if it equals 4. 15 plus 1 is 16, and the square root of 16 is 4. Number 2. We have the square root of the quantity 2t plus 15 equals t. All right, so yes, we have t by itself, but there's also a t inside of the radical. So we have to undo the radical to get to that other t. So we square that, and we square that, leaving us with 2t plus 15 equals t squared. All right, so anytime you get a variable that has an exponent on it, now we're dealing with quadratics and we're dealing with different styles of solving. So we're going to have to move everything over to the same side, because remember when we solve quadratics, we want it to be set equal to 0. So if you see, I did a little bit of flip-flopping, but you can still see that where t squared is, it's negative 2t, negative 15. Okay, so we can try to factor first. I would always recommend trying to factor first. If you can't factor, then I would just go straight to the quadratic formula. Remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. So if you cannot factor, just go straight to the quadratic formula. All right. The factors of 15 are 1 and 15 and 3 and 5. And do any of those subtract to give us 2? Well, of course, 3 and 5 do. But it subtracts to a negative 2 and it multiplies to a negative. So that means our larger factor needs to be negative. So now we have t plus 3 times t minus 5, and it's still set equal to 0. And then to finish solving, set both factors equal to 0. One thing that, Was I out of the window? I'm sorry. If I was out of the window, my bad. That's what I did. I solved. One thing that you might notice, -3, it says is extraneous. Well, what does that mean? Well, let's see. So we gotta check our answers. All right, this right here, you don't have to go any further to know why this is extraneous. Do you think you know? It's because a square root cannot equal a negative. Okay? A square root cannot equal a negative number. So that's what we call extraneous solution. It gives you an imaginary value. And let's check to see if our other one works. I mean, maybe both are bad. All right, so t equals 5 is the only solution. Okay, so all of this stuff in here should be refreshment, reminder. We have done that before, but that is not the focus anymore. Okay, so I'm not going to spend a whole lot of time rehashing that out because it's something that we have done. And let's go one more together. The square root of p minus 4 equals -5. Okay, just as when we were checking our solutions over here, oops, you don't have to go any further. Why? Because a square root cannot equal a negative. No solution is your answer. A cubed root can equal a negative, but a squared root cannot. In fact, let's just make that a broader statement. Even roots cannot equal a negative, but odd roots can. Let's do one more, actually. Let's do number... let's do 5 and 6. Okay, so if you have a squared on both sides, well, if you wanted to get this s by itself, you'd have to square this side. And if you do that to the left, you have to square this side. So looky there, it just cancels out. And that's all the further I'm going to go on that. Notice we have a squared root, so you have to solve it with quadratic strategies. Okay, I am going to jump to number 6 though. All right, so when we were under a squared root, we squared it. When we are under a cubed root, we cube it, okay? You always have to do whatever is presented in the equation. So the opposite of a cubed root would be cubing a number. And 4 cubed would be 64. Okay. Again, up top, there are examples typed out, nice, pretty examples of solving. Okay. And Again, the answers are there for you. It's not about the answer. It's about the process of finding those answers, but it's a nice, good check for you. All right. I hope this is straightforward, and happy mathing.